In this video, this is a quick recap about Pythagoras' theorem. What you should know or remember when you studied it in Year 8 is that Pythagoras' theorem is used to work out the lengths of sides of right-angled triangles. And when we work out the lengths of the sides of the right-angled triangles, we use squares. We give this letter, A, B, and C, where C is the most important side. It's the hypotenuse, the longest side, the one opposite the right angle. And what Pythagoras' theorem says is if you take the square of A, add it to the square of B, that gives you the square of C. So you will recall that Pythagoras' theorem is A squared plus B squared equals C squared. And this could be rearranged two other ways. You can make A squared the subject, or you can make B squared the subject. Making A squared the subject, you get C squared minus B squared. And making B squared the subject, you get C squared minus A squared. And these formulas will always be on the formula sheet, but you should use them, know how to use them, and learn them. I'm just going to do a quick couple of examples on how to find the hypotenuse and then how to find one of the smaller sides. So let's look at finding the hypotenuse first of all. Let's do the most easiest triangle of all. Let's do a 3 centimetre triangle and a 4 centimetre triangle. Now you should know that this is a Pythagorean triple. It's a very famous triangle. So we should find out that the hypotenuse is 5 centimetres. But let's just check this. So labelling this as, say, side A, this is side B, and this is side C, we get A squared plus B squared plus C squared, equals C squared, is 3 squared, which is 9, plus 4 squared, which is 16, equals C squared. So we get 9 plus the 16. 9 plus 16 is 25. The square root of 25 is 5. Therefore, C, hypotenuse, is 5 centimetres. Let's have a go at working out one of the smaller sides. Let's pick a different triangle. Let's go with a hypotenuse of, 10 centimetres. And let's go with a smaller side of 8 centimetres. And of course, you're not always going to get whole numbers when you work these out. It's just my examples are going to involve whole numbers. So first thing, label the triangle. That's the hypotenuse C. A and B are the smaller sides. And I'm trying to work out what A is. So I can either use this formula here, the A squared, or I can just substitute it in this and rearrange it later. It really doesn't matter. As soon as I've rearranged it and it's here, I'll use this one. So A squared equals C squared minus B squared. So A squared equals, well, C squared is 10. 10 squared is 100. B is 8. 8 squared is 81. Sorry, it's not. It's 64. Hang on. Momentary lapse there. 64. Apologies. 100, take away the 64. It's 36. So therefore, A is the square root of 36. Which is 6. And of course we're in centimetres. So 6 centimetres. And that just gives you a quick recap of how Pythagoras' theorem is used.